So we also have this exam coming up, right? So how do you study for one of these things? Well, obviously, one of the best ways you may have picked up is doing practice problems. But I think one of the things that's often missing when you're studying for exams is actually thinking carefully about how you're thinking, right? So when you're doing problems, it is nice to have other people to critique your approach, or for you to critique their approach. And so long ago, I took this graduate probability and statistics class that was just so murderously insane difficult. And so our approach, which you may find useful, is we would every week there was a homework, or when exams were coming up, we'd have a set of problems. We'd all work through them on our own. And maybe we'd get all of them. Maybe we wouldn't. Usually, you get stuck on a couple of them because they were super hard. And then we'd get together as a group of 5 people, and one person would go up and start showing their solution, and everybody else would call out things along the way, like, oh, I didn't know you could do that. Like, I didn't know that identity existed, or I didn't know that was a trick you could do. Or you call out and say, there's a much better way of doing that. You're going way out of your way. Did you not notice when we had Sentinel nodes? Okay, well, that'll make your life easier, right? And by reflecting on how you're thinking about things, not only does the person you're helping learn, but you learn. You get an understanding of the space of different ways of approaching problems, okay? So I would say reflecting is a really good idea, and it's best if you could do it by other people you meet. So Monday, if you don't already know people in the class, start finding friends, or after class today, or organize on Piazza. Another thing I want to highly recommend is that there's this studying technique where you just go look at the solutions to an exam, and you look at each line, and you're like, okay, I got it, right? You may have learned that's not very useful because we are going to give you new problems you've never seen, and therefore you have to understand things. And I'm not a trivia guy, right? I don't like to write exams where I just ask you silly, pointless trivia. I want you to really think. And so looking at the old exams is a good way to get more such problems. So there's the Gorilla sections over the weekend. I should have posted those here. And we'll also send out an email that HKN is doing a review session, though. Anybody know when that is? No? Okay. And if you want some more tips, well, I got a couple of Reddit threads that had good thoughts that people had. And I've even written my own thoughts on how one might study. Okay? So good time to start as soon as you finish Project 1, because part B of the project will be relatively chill. Yes? Last semester we did random extra credit questions. So Paul always does a random question about anything in the whole universe and makes them 1 point out of 20. I make them 0 points. Okay? But they'll still probably be 1, but it won't be for credit. Yeah?
So for the, if you don't get full credit for, Project 1A, so where that figure of value of Project 1B and 1C, which, some code will make...
I see. So Project 1B is built such that even if Project 1 is totally broken, it's fine. Okay? Yeah. Though your life will be easier if you have a working Project 1, but you could do 1B without 1A. All right. Good question. Cool. All righty. So, words. There are a lot of crazy-looking words on this slide. Well, today we're going to be talking about inheritance, and even if most of you have seen inheritance, E7 people. Does that phrase seem familiar? E7? Who's E7? Okay. Seem familiar? Inheritance? No. All right. Well, it'll be a fun ride. Ready? Okay. Many of these words will not be familiar, and even if you know inheritance, you'll probably see it in a different way than you've seen before. Okay. So if you take the A-list and S-list classes that we built throughout Lecture 4 and 6, if we then take those tricky insert methods that you guys did in discussion, you may remember these guys being particularly hard, especially in S-list. If you add that method in, you end up with 2 classes that basically do list stuff, right? So the A-list, you can insert into it, you can insert into the front, the back, get back, and so forth, right? And it's a slightly different interface than the deck that you guys did on Project 1. Okay? But related idea, it does list stuff. So the only thing different between these 2 methods is the name of the class and the implementation. But otherwise, all of their method signatures, and a method signature is just the definitions, public, void, insert back, blurb x. All of the definitions are the same, and I have a slightly different generic type. Okay, great. So they're both lists. Now let's suppose we want to write some kind of a library that manipulates lists of words. Okay, let me open up a terminal. And we'll just do an attempt directory. Hello. Okay, and I'll copy the DIY folder. And then we'll be good. Okay, Copy in, files. Nope. Oh, that's so loud. All right, there we go. So let's suppose we write ourselves a class, wordutils. Okay, and what it's going to do is it's going to have various things you might want to do with words. And here I might imagine having a function called longest. And I have it already pre-written here because it's not really anything different than you've done before. Okay? I'll go through it really quick. But basically all it does is given an S list of strings, it finds the longest one by iterating through and using a pattern that you're very used to. Okay? All the little details don't really matter. It's just, hey, look, we're calling functions of lists. Okay? So if, for example, we'll just double check and make sure I didn't mess it up right before class, but when I was messing with it. But here, if we have some list, if we insert a bunch of strings into the list, elk are watching, and we print it out, we get watching. Okay, good. So longest is working. Okay, so that's the scene that we've set. All right. Oops. Let's see. All right. So you can imagine such a function might be useful, but there are some issues. Okay. While this works beautifully for S lists, right? If instead I were using a list, like a list string equals new a list, everything's just the same. But if I try running this function, I get, of course, an error. I can't turn a list into an S list. So when you try and call this function, you can't copy the address of an a list box into an S list container, okay, or an S list box. So normal situation. Okay. So suppose we want to be able to handle a list with what we know so far in 61B. How could we do it? We don't know about that yet, though. So something we've already seen. Yeah. That's an interesting thought. We could try and do some kind of generic type. That would be very fraught, though. So you're saying, like, replace this with, I don't know, something like that? I don't know. Yeah. I think you'll run into trouble. There's a more brute force approach. Uglier. Yeah? Yeah, just make another longest method. Okay, cool. Copy, paste, a list. Done. Okay? Now I have two functions, one that's for S lists, one that's for A lists, but that's not so great for reasons that we will discuss. Okay? So the only thing I do, see S list, change that letter, A. Done. That's the whole magic. Okay? So Java lets you do that. Java lets you have multiple methods that have the same name but different parameters. So I can have two functions called longest, and this is something called method overloading, right? There are multiple methods called longest. They just happen to take different types of parameters. And we've actually already done overloading. So if you look at the sort code from the last lecture, we had a public method called sort and a private method called sort. So while this works, I'm going to say it's a bad idea. And I want you guys to give me some reasons why this code is no good. Yeah?
Because you copy yourself, and also, code also takes memory. So, takes extra, unnecessary memory.
Okay, so our source code files are unnecessarily long. We have a lot of hard drive space, but that's true. Okay. Yeah. That's it? Yeah. Well, okay. Yeah. And why is that bad, though? As you mentioned. What's actually bad about repeating yourself? Just seems aesthetically gross. Okay. Yeah? Yeah. More code to maintain. Okay, give me an example of what you mean by that. Why do you have to maintain it like it's there? Okay. So any change made to one must be made to another, including, for example, bug fixes. So if you find that there's a bug, and then you fix it with S-list, you may forget to do A-list. That's a major problem. This is brutal. All right, other? Anything else? Yeah? Harder to use in a way. Oh, I guess you have to know what kind of types. Well, let's actually, I think maybe a different version is, suppose we make another list someday. We'll need another function. Because actually we don't need to know which function we're calling, because Java will automatically call the right function, right? But that's, suppose we have another list someday, we'll need yet another function. Okay? Those seem like pretty good lists, unless somebody else has anything else that comes to mind. All right. So we would like to fix that. Okay? Well, we have a similar